The problem is a mechanism is as shown in figure having the following dimensions. O1A equal to 60 mm, AB equal to 180 mm, O2B equal to 100 mm, O2C equal to 180 mm, and CD equal to 270 mm. The crank O1A rotates clockwise at the speed of 120 rpm. The block do moves in a vertical guide. Find the instantaneous center method. By instantaneous center method, the velocity of D and angular velocity of CD. That is the finding which you have to find for this given space diagram. The very first step is you have to calculate the velocity of crank O1A. That velocity can be calculated by using the formula which is given here. As we know the speed that is of crank O1A that is given 120. So by using the 2 pi n A01 divided by 60, you will get the omega. That omega is 12.56 radian per second. After getting the omega of link A01, you have to calculate the linear velocity of A01. That is omega multiplied by length A01 in meters. So 12.56 is the omega of A01 multiplied by 0.06 is the a meter is the length of the A01. So we'll get the velocity of first link, that is the A01 is 0.7536 meter per second. This is the very first step. We have to find out the velocity of the crank at very first site. Then you have to draw a space diagram. So to draw the space diagram, you have to assume some suitable scale. So the scale we have assumed here is 1 centimeter equal to 60 mm. That scale we have taken. With this scale, we have drawn a space diagram. This is the space diagram. This is the space diagram which is drawn for the given assumed scale, that is 1 centimeter equal to 60 mm. Now second step in the ICR method is give number to the link. These are the different links. So see here, this is the first link which is the fixed link. Then O1A, this is the link 2. So put the number to the all links. Link 3, AB is the link 3. Then O2C is the link 4. C to D is link 5. And this slider is a link 6. In this way, this mechanism consists 6 linkages. Now, for all these 6 linkages, as per our step, give the number to the links. We have given that. Then you have to find the number of ICRs for this mechanism. The number of ICRs capital N is given by n minus 1 divided by 2. Small n is nothing but number of links. Number of links in this given mechanism. So already you have given the number to the links. So total 6 links are there. Means n equal to 6. 6 minus 1 divided by 2. It is 30 divided by 2 equal to 15. So number of ICRs for this mechanism are 15. But remember that all 15 ICRs are not necessary to locate until unless they have not asked you to find locate all ICR. You are not. It is not required to locate all ICRs. So here, what is your finding depends upon that. You have to locate only those ICRs which are required for your calculations. So we'll see that which are the ICR required for our calculation later. But as for the step number 4, you have to prepare the ICR list in tabular form. So what are the ICRs? That 15 ICR you have calculated. What are those 15 ICRs? So you have to make one table. That links, first column contains the links. Second column contains the ICRs. Links are six. Already you have calculated 1, 2, 3, 4, 5, 6. These are the links. Now in ICR, you have to write I want to, means you have to just make a combination of link 1 with all remaining links. So I want to, I want 3, I want 4, I want 5, I want 6. In the same fashion, you have to make the, for link 2, you have to make the combination of link 2 with the remaining links except 1. So I23, I24, I25, I26. In this way, the fifth link will have I56, only one ICR. So if you count this number, you will find that total 15 ICRs are there from this table. And it is matching with your calculated ICRs. So this is the step of making the ICR table. So after making the ICR table, you have to mark on your space diagram. This is the space diagram. Those which by visualization that ICS you can locate in your space diagram. So what are those ICS which you can locate in your space diagram? That is, first one is a fixed ICR. Already you knows the ICR types. And second one is the permanent ICRs. These ICRs you can locate by naked eyes. So locate these fixed and permanent type of ICRs in your space diagram. So we are going to locate that. See here. Here between link 1 and link 2, we are having at this pin joint, we are having ICR 1, 2. Between link 2, this link O1A and AB link, here we are having ICR 2, 3. Between link 3 means AB and O2C link, here at the B we are having ICR 3, 4. Between link 1, this is the fixed link, and O2C link, that is link 4, we are having ICR 1, 4. Between link 5 and link 4, this is the fifth link and this is the fourth link at C, we are having ICR 4, 5. Between link 5 and this slider, we are having at this pinpoint ICR 5, 6. Now remember, for the slider, the ICR is a perpendicular infinite line, means to the line of stroke of that slider. The line of stroke of the slider is vertical. The perpendicular to this line of stroke is a horizontal line which is passing through the pin of that slider. So this is the ICR of 1, 6 at infinite. At infinite. So 1, 6 will be the perpendicular line to the line of stroke of this slider. The slider is having line of stroke vertical line. So ICR will be a horizontal line for 1 and 6. So in this way, you have to locate all the ICRs by your naked eyes, right? So we have located all these ICRs. See here, 1, 6 is located like this. Not only you have to locate I16 at the slider position, wherever you are having the fixed positions, there also you have to locate the ICR 16 at infinite. So two fixed positions are there. There also I have located the I16 at infinite position. So all the permanent and fixed ICRs are located in the space diagram. Then in your table, you have to round up all the ICRs which you have located already by visualization, right? So these are the ICRs which we have rounded up. These are the ICRs which already gets located. So all the rounded ICRs already located. But the ICRs which we have not rounded, that you have to locate. But in this case, you need not to locate all the ICRs. As I said that, locate only those ICRs which are required for your calculations. So how to find out that which ICRs you have to locate? To find out that, again, what you have to do? You have to draw the circle diagram, locate all the permanent and fixed ICR which you have already located. So I want to, here I want to, that I have shown in the circle diagram, I23, which already we have got here. All the ICRs which already have located, that you have to join by the lines. I14 is also there. So all the permanent and fixed ICR which already you have located, which you have rounded up in the previous table, that you have to show in circle diagram. But the main part is this: find out which ICRs you need to locate for your calculation. For that, on the rough paper, rough page, you just make one table. What table? The table column contains what you knows that will come, and what you have to find out. Second column is what you have to find out. First column is what you knows that you have to write down. Now, on which link your finding or what you knows will come, that link number you have to put in the third column. And related with that link, you make the ICR list. Means link is 2, then you just make the ICR 1, 2. You just make the combination with first link, pixel link, for that link 2. This is the rough table which you have to make on the rough paper. It is very useful, important table, because by drawing this table, you will come to know that which ICRs are necessary for my calculation. So what is? We'll start with the first. What is known to you? Omega 2. Means the omega of link 2, this link is known to you, is known. So if omega 2 is known, what you can find out? You can find out the velocity of first link, which already we have done in first slide. So velocity of A is calculated in first slide. Now where omega 2 will come, on which link? Link number 2. Omega 2 is referred with the link to. So I have written the link to here. So make the link to combination with the fixed link. So ICR will come. Required ICR is I12. So this is the first row which we have completed here. Now by doing this first row, we got the velocity of A. The second row start with the what you find previously. What we find? Velocity of A. Now that is known to you in second row. So velocity of A is known. Now this A point, if you come here on the A, this A point is the point, common point of link 2. This is the link 2 and this is the link 3, and A is coming here. So A is the a common point of link 2 and link 3, and that with that A, which already have calculated velocity of A, now we have to consider the next link, omega. Omega 3 you can easily find out because I knows the velocity of A. So just go for what you have to find out, the omega 3. Now omega 3 means A point is appearing on link 2 and link 3 that I have written in the link column. Now what are the ICR related with 2 and 3? ICR 1, 2, ICR 1, 3. These are the two ICRs which are related with the link 2 and 3. Now what we got here? Omega 3 we got here. Now after getting the omega 3 here, omega 3 is known. Next column will be the omega 3, which is known. We have calculated previously. That will be the known thing now. Now, if you know the omega 3, you can easily find out the velocity of B, because I knows the omega 3 now. If I knows the omega 3, I can easily find the velocity of point B. So that I have to find out omega B. So omega 3 is related with which link? Link 3. So ICR related with link 3 is I13, that I have written in last column. Now after calculating this, I will get the omega velocity of point B. The velocity of point B will be known to you now. Now if velocity of point B is known, that will come in next row, that velocity of B is known. If velocity of B is known, now this B point is the, you can see here in the your diagram, B point is the appearing on link 3 as well as on link 4. This is the link 3, AB, and link 4 is O2C. So B point is here. So B point is the common point of link 3 and link 4. So velocity B is known to you. So it is easy to find out the omega 4 by knowing the velocity of B. So velocity B, for velocity B, I have taken the link involved is 3, and omega 4, I have taken the link involved 4, because both links are involved. So ICR related with 3 and 4 link is I13 and I14. So in ICR column, required column, I have written I13 and I14. So I knows the omega 4 now. Once you knows the omega 4, it is easy to find out. Let me erase this. Now omega 4 is known to you. That will be the input to your known thing. Now by having the omega 4, what you can find out? I can find out the velocity of C. So that I have to find out omega C. Omega 4 is related with link 4. So ICR will come in the last column is I14. Now by doing this step, I knows the omega C. Once I knows the omega C, I can find out the omega 5. So omega 5 will be the your finding. Now omega C and omega 5 will involve, or omega your VC is involved with link number 4 and 5. It is the common point of 4 and 5 link. So I have to find out I14 and I15 here. I have to write I14 and 15 here. Now after getting the omega 5, this is the input to the next row. So omega 5 is known to you. If omega 5 is known to you, you can easily find out the velocity of D. So omega 5 is related with what? Link number 5. So ICR is 15. So this is very important table. Now you might be thinking how I will get which ICR need to locate. Now see here the list of ICR which you have located in last column. I12 already available. I12 already available. I13 is not available. I13 not available. I13 not available. I14 already available. See here. I14 already available. See here. I14 already available. Not necessary locate. I15 not available. Underlined it. I15 underlined. So from this table, I come to know that I13, which I have highlighted by red pen, means I13 and I15 are the two ICRs which are enough for your calculations here. So remember this table, you have to make on the rough paper so that you will come to know that I have to find out the ICR 13 and 15 only for my calculations. So next step, you have to locate the ICRs. Already you have calculated, I have to locate the I13 and 15. Here I have written. So ICR 13, to locate the ICR 13, join the 1 and 3. See here, I have joined this in the circle diagram. 1 and 3. This is the 1, this is the 3. I have joined it. And this ICR I want. Now to have this ICR, you have to just see the triangles. Which triangle is there? For ICR 13, you will get by Kennedy's theorem, by referring the first triangle, this will be in line with the I12 and I23. See here, the sides of the triangle, 1, 2 and 2, 3. So that I have written here. Similarly, other triangle of I13 is this triangle. So this triangle shows that I13 also will be in line with 1, 4, ICR 1, 4 and 3, 4. So as per our calculation, you need to only locate the ICR 13. What I did, I joined 13 here. I have checked the triangles, two triangles of that I13. One triangle is, you will get I by the in I13 will be in line with the I12 and 23. See here. So I13 is in line with the I12 and 23 and 14 and 34 by using the second triangle. So now you have to look at that. Where is the I12? I12 is this ICR. Where is the 23? 23 is the this ICR. In line with this, your ICR 13 will come as per Kennedy's theorem. Now, second triangle says that I14. Where is the I14? Here is the I14. And I34. I34 is here. So this line of I14 and 34 and line of 2, 3 and 1, 2, where it will join, there you will get I13. Now I have that animation also. I will show that. See here. I have drawn the ICR of I12, ICR of 2, 3 as per this. Then second set is I14 and 34. I14 and 34. I have joined the line. I will get the ICR 13 here, where the lines will get intersected. That is the ICR 13. What Kennedy says, if three links are having relative motion with each other, they will form the three ICRs, and that three ICRs will be in line. See, this I13 is in line with 14 and 34. I13 is in line with the 1, 2 and 1. This is the Kennedy's theorem. So we have located the I13. After locating the I13, we have to locate the I15. To locate the I15, we have to join the 1 and 5. So I have joined this 1 and 5, and I have just checked the triangles of that 1, 5. One triangle is one made by side 1, 4 and 4, 5. Another triangle is here one, that is by the side 1, 6 and 5, 6. So the ICR 15 will be the in line with the, by these two triangles will be the in line with the 1, 4 and 4, 5 triangle and 1, 6 and 5, 6 triangle side. So how to look at that? Just draw the line from 1, 4. Here is the 1, 4 and 4, 5 is here. The line will get extended from 1, 5 and 4, 5. Then second triangle says that 1, 6 and 5, 6. See here, this is the 1, 6. And where is the 5, 6? This is the 5, 6. So 5, 6 and 1, 6 line is this. 4, 5 and 1, 4 line is this. They will intersect here, and this will be the ICR 1, 5. So you can see this by the animation. See here, I15 is in line with the 16 and 56 ICR, and second set is 4 5 and 1 4, this line. So we have located only those ICR which are required for the calculation. Now comes the calculation parts. Calculation is more in ICR. First calculation, you have to calculate the velocity, which already we have calculated in the first slide. We know the omega of crank. We know the length of the crank. So we got the velocity of 0.7536 meter per second. By knowing the velocity of a point, that is VAO1, O1 is a fixed, that's why I have written here velocity of A. That formula I can write as, because A is the point of combined point of link 2 as well as link 3. So I have written that velocity of A is can be written as omega 2 I12. When I consider a point on link 2, I have considered the omega 2. So I have written I12 multiplied by the distance up to that A point, equal to also, I have considered now to write this, I have considered the A point is a part of link 3. So I have taken the omega 3 multiplied by I13 multiplied by distance up to that A point. So this will be the formula. Now, by writing this formula, by considering the A point is the combined point of 2 and 3, I have written this formula. Now, already you know omega 2. Forget about that. We have to find out the omega 3. So velocity A is known. Omega 3 you have to find out. I13 you have located. 1 3 to A distance you know that you have to put here in meter. Omega 3 will be 1.7 radian per second. See this I13 calculation. I13 calculation, I have measured the distance I13A, that after measurement it is 7.38 centimeter, multiplied it with the scale which you have taken already 60 mm. So that is 7.38 multiplied by 60. You got the 442.8. I have to bring it into meter, divided by 1000 to this. You will get in meter 0.4428 meter, right? So this is the I13 distance which I have shown here, right? I got the omega 3. Now after getting the omega 3, you can find out the velocity of B. Velocity of B is nothing but the omega 3 multiplied by I13 into उस point तक का distance B, the distance of that ICR to B point. So already we got the velocity omega 3. Put the value here. We know the I13B distance because you have located the I13. Convert this I13B as usual. Here I have shown that distance I13B, measure distance 5.52 centimeter, multiply it with the scale. We got it 331.28 mm. Divided by this mm by 1000, you will get in meter. So we got the velocity of B 0.5. After knowing the velocity of B, we can find out the omega 4. To find out the omega 4, B is the common point of link 3 and 4. So write the equation of velocity of B by considering it on link 3, then by considering on link 4. So we got the omega 4 here. So that calculations of I14B I have shown here. So omega 4, after getting omega 4, we have to find out the omega C. Omega C, already you got the omega 4. Put this here, you will get the omega C, so velocity of C. After getting the omega velocity of C, you have to find out the omega 5. Once again, this is the calculation of omega 5. I am not repeating because I have explained in previous step. So by considering the omega C is the point of omega link 4 and 5, you write the equation. From this you will get the omega 5. How to measure the distance? That comes here. So we will get the omega 5 1.65 radians per second. Then after getting omega 5, it is easy to find out your finding, that is velocity of D. Velocity of D is nothing but omega 5. Consider that D point is on link 5. So omega 5 multiplied by I 5D. So I 5D calculation I have shown here. This. So in this way, your calculation overs. So in ICR, your calculations are more, but you need to understand this. So here ends the numerical. Thank you. Thank you very much.